For question 2, we are shown a car of mass 1,300 kilograms ascending a hill inclined at an angle of 20 degrees to the horizontal. We're told that the coefficient of friction is 0.25, which immediately tells us that there is friction. If it's ascending the hill, the friction will be acting down the hill. We're told the tractive force produced by the engine of the car is 12,000 newtons, so the force pushing it forward is 12,000 newtons. We've then got the weight of the car under gravity, which will be 1,300 G, and the normal reaction perpendicular to the surface. So that's our diagram labelled. That gets us our 2 marks. Very, very straightforward, just writing on what we know, and now we can work towards finding the acceleration of the car. So because we have it accelerating, we know that it's not coming off the road. So it's not bouncing along the road, it's travelling smoothly along the road. So in terms of the vertical forces, they are going to be in equilibrium. So the first thing we can say is that R is going to be equal to 1,300 G cosine 20. Okay, so that's resolving that into the plane, and in a minute we'll resolve that down the plane. We can work out straight away what that R is. So that will come out as 11,971.68 newtons. So we're going to use that in just a wee minute to work out the acceleration. So when in motion, we're told that the car is in motion, so when in motion, it's obviously accelerating. Friction is going to be at its maximum, so friction is going to be F max, because it's obviously going to be trying as hard as it can to stop the car moving, but its best is not good enough. So that's going to be 0.25 multiplied by our 11,971.68, which will give us a friction of 2,992.92. So we've worked out what friction is, which means when we can apply F equals ma to the moving system, we've got our friction. So if we apply F equals ma, we're going to have 12,000 minus the friction minus the 1,300 G cosine 70, or sine 20, whatever you prefer, and whatever you're looking at, and then that's equal to 1,300 multiplied by our acceleration. We start to pop in everything that we know. We'll have 12,000 minus our 2,992.92 minus the 1,300 G cosine 70. That's equal to 1,300A. All we have to do is put that all into our calculator, which will come out as 4,649.473 is equal to 1,300A, which will give us A is equal to 3.58. That's meters per second squared, and that's rounded to 3 significant figures.